Okay, so now we're looking at, we talked about horizontal, now we're going to look at vertical. Vertical ones, we have a few other things that happen, right? Rules to finding holes in vertical asymptotes. The domain is going to be all real numbers except those values that are going to make the bottom equal to 0. That's our no case, right? So holes are our zeros of the denominator, right? So it's going to be that restriction that divide or cancel out, because now we can have that case. Vertical asymptotes are values in the bottom that do not cancel out. So we have a few examples. Determine whether the graph of the rational function has a vertical asymptote or removable discontinuity, both or neither. List them, right? So the top factors into an x plus 2 and an x minus 2. The bottom factors into an x plus 3 and an x minus 3. So, oh, not minus 3, sorry guys. That's a plus 2. So right here, I know two things. X can't equal a negative 3, and I know x can't equal a negative 2. So here we are, a negative 2. So when I look at stuff that's going to cancel out, x plus 2, x plus 2, right here, because those cancel out, I know that when x is equal to a 2, because it can't equal it because it'll make the bottom equal to 0, I'm going to have a hole. Okay? On this one, when x is equal to a negative 3, because that doesn't cancel out, x is equal to a negative 3, I'm going to have a vertical asymptote. Okay, next part. Here we go. 14, factor the top, factor the bottom. The top factors out into an x and an x minus 1. The bottom factors into this x plus 4 and an x minus 1. Okay, I know the bottom cannot equal a negative 4 and a positive 1. So here we go. Those go away, so I know right there when x is equal to a 1, I'm going to have a hole. Right? When x is equal to a 4, I'm going to have a vertical asymptote. I have this graph for us in Desmos. And in Desmos, you can see over at that negative 4 spot, you have, right? So it's the same thing. It's graphed right here, right? It's the reverse. I have it undefined. So that's what one of those are going to look like. So I have this and I have that, and it's for that one right there. So coming back, let's do our next one, our last but not least. I have the same thing on top and bottom, right? So stuff's going to cancel out. So here we are. I get an x minus 7, x plus 2. I get an x minus 7, and I get an x plus 2. I know x cannot equal that 7 or that negative 2, so those cancel out both of them. So this is the thing. When x is equal to a 7 and a negative 2, because they cancel out, I'm going to have a hole.